Good afternoon, ladies and gentlemen, the Honorable, all the committees, presenters, and participants. First of all, in this insightful session, allow me to thank for this great opportunity that has given to me to share my thought and present the article with the title IndoBERT-based data augmentation for Indonesian text classification. I am Fuad Mufti as the author and speaker here, and I'm with Dr. Muhammad Haris MN as the co-author. We are from Indonesia, Nusa Mandiri University, Jakarta. Ladies and gentlemen, and now we are going to move on to the main presentation. Introduction. Natural language processing, or NLP, is still a growing research topic in a wide range of fields, including text classification, document summarization, text translation, sentiment analysis, text generation, and more. One of the challenges in NLP is providing large text data to avoid model overfitting. And NLP needs huge data training to make a strong model. And we know that even though text data is abundant, in certain cases, it is still face data limitation for specific purposes or in specific domain, such as sentiment data for an emerging trends. Then to overcome the limitations of data availability, data augmentation techniques are employed as a strategy to increase the training data without the need for collecting new data. Because we know that collecting new data sometimes can be very expensive and time-consuming. Various augmentation techniques are able to make huge data text as needed, but there are still challenges where changes to the text in augmentation can change the meaning and change the sentiment of the sentences. So in this study, we aim to find effective solution for augmenting Indonesian text that can maintain the meaning and sentiment of the sentences. And also, the augmentation techniques must be able to provide a good generalization for the model. Related studies, Wei and Zhu applied 4 augmentation techniques called easy data augmentation or EDA, including synonym replacement, random insertion, random swap, and random deletion for some words. Duong and Nguyen Thi used back translation, syntax tree transformation, and EDA for data augmentation to perform sentiment analysis on limited Vietnamese text datasets. Yu et al. Proposed a data augmentation method called hierarchical data augmentation or HDA applied to text classification. Research contributions. The contribution of this study is the selection of text pre-processing methods for Bahasa Indonesia and combining the use of post-tagging and IndoBERT to create limitation data from Bahasa Indonesia text dataset by selectively inserting words in sentences. Research methods. We use method as shown in this flowchart. First, dataset. We are using 2 Indonesian public datasets. 1, the dataset for hate speech detection in Indonesian. 2, Twitter sentiment analysis dataset. The dataset contains 1,400 rows data with 2 classes. And then second, pre-processing. There are 2 block main pre-processing data here. 1, data cleaning, including delete unnecessary words, delete emoji, remove non-ASCII characters, remove links and HTML elements, remove numbers that stand alone, and case folding or make the text lowercase. 2, normalization, to change informal words or abbreviations to become more formal words and remove duplicates data. Third, data splitting. We divide the data into 2, 80% training data and 20% testing data. Fourth, training data augmentation. Here we are using 2 methods of data augmentation. 1, using language model or IndoBERT for augmentation as main method. And second, using random insert EDA that we use as a comparison. Fifth, feature engineering the data with tokenization and vectorization so that the data is ready to be used in the deep learning model. 6. Deep learning model using CNN and BLSTM. In the training process, we train the model each using 3 training data: the original data training, the augmented data training using random insert, and the augmented data training using proposed augmentation method with IndoBERT. 7th, model evaluation. We evaluate the performance model using 2 matrices, accuracy and F1 score. And we also use blue score to score the similarity of the augmented data. Data augmentation technique. This is a picture of an example of text data augmentation process from input text, augmentation process, and then output text. The main point here is that the augmentation should keep the result as a complete sentences, the meaning doesn't change, and the sentiment doesn't change as well. So we propose augmentation techniques as follows. From the input text, the algorithm will find part of speech tagging of the text, and then based on that post-tagging result, set the location to insert the word by order. It should be follow the sequence from verb, preposition, adjective, conjunction, etc. Meaning that the first priority in inserting words is around the verb, and then around preposition, and so on. We choose this sequence based on the observation of 200 text augmentation in Bahasa Indonesia at all possible positions, and we got good results on that sequence. Then insert the masking token at the selected position. Then we did unmasking using IndoBERT to get word list as the candidate word to be inserted in the text. Then filtering the words list with certain criteria, including it's not stop words, not subwords, negation, etc. And the last, it insert the selected word into the sentences. To test the augmentation method, we use deep learning model as text classification model using CNN and BLSTM. The picture shows the model of CNN and BLSTM. For CNN, we use 4 layers. For BLSTM, we use 6 layers, as shown in the picture. With this model, we train 3 sets of training data: the original data, data with EDA, and data with IndoBERT augmentation. We train each model with each data for 10 times. Then we take the average score and compare each results. And this is the result of our experiment as shown in the table. We know that by augmentation of training data, we can gain higher score of accuracy and F1 score compared to base result. In CNN model, we can achieve higher accuracy score using IndoBERT augmentation in both dataset. But for F1 score, higher score can be achieved by IndoBERT model on dataset 1. On dataset 2, the random insert model still get higher score. In BLSTM model, we also achieve higher accuracy score using IndoBERT augmentation in both dataset. But for F1 score, higher score can be achieved by IndoBERT model only on dataset 2. On dataset 1, the random insert model still get higher score. And last, for the blue score, we got average total score of 88.91 for dataset 1 and 88.25 for dataset 2. It means the augmentation can give the similar of the original dataset. And then conclusion, text data augmentation using selective insertion by utilizing IndoBERT can assist in improving the performance of deep learning models in CNN and BLSTM by increasing accuracy and F1 score. For further development of the selective insertion method, experiments can be conducted by inserting more words into sentences, especially for long text data that require more data to be used in deep learning model. That's the end of my presentation about IndoBERT-based data augmentation for Indonesian text classification. Thank you very much.